As an infrastructure as code tool, Pulumi has support for a number of popular cloud providers, infrastructure tools, databases, source control systems, and so on. But inevitably, many of us will encounter a situation where we want to use Pulumi with some service that it doesn't yet support, or possibly even want to use Pulumi with a service that we've created ourselves. Luckily, Pulumi is flexible, and we actually have two options to go about supporting some new service. The first option is to write a full Pulumi provider, just like the providers that it already implements from scratch. Now, a quick disclaimer, I've never actually tried to do this myself, but I can tell you that these providers are written in Go, and therefore they have to be compiled to machine code, so you're going to have to compile them differently for each platform that they run on. And so generally I would think of as a heavyweight solution. Probably if you were going to go about writing a new provider, you would kind of consider that a whole project in its own right before you actually use it as part of your stack. The second option is to write a dynamic provider. Dynamic providers are written in the same high-level language as the rest of your infrastructure definition, so TypeScript or Python or whatever it is that you're writing in. As a result, there's no compilation step needed. You just import your dynamic provider into your main Pulumi program. And so I would think of these as much more lightweight. I would say that you can implement dynamic providers as part of your ongoing stack development as and when you need them. Over the last year or so, I've written quite a few dynamic providers. So in this video, I'm going to focus on that second option, and I'm going to talk you through the implementation of a dynamic provider from scratch. And as I go along, I'm also going to try and point out the various caveats and pitfalls that I've encountered and hopefully avoid you getting stuck on those same things. For this demonstration to work, we're going to need some kind of service that we want to write our dynamic provider for. And for simplicity, I've implemented a mock service that I'm going to use for demonstration purposes. If you want to follow along with this video, I've made the code available and I'll put a link in the description. It's a very simple express service that is a mock of some kind of cloud-based database provider. And the idea is that our database provider allows us to create tables, a bit like if you were working with a service like DynamoDB, for example. So just like a real service might do, this service exposes some endpoints that let us manage these table records. We can get them, we can create them, we can update, and we can delete them. Note that my mock service doesn't go any further than that. It's not actually a database provider. It just manages these records of tables, because that's all we need for this demonstration. So the first thing I'm going to do is start running this mock service API. So if you want to follow along, you just do that by running node index.js in the root directory. We're also going to need a Pulumi program, so I've created a completely blank Pulumi project here in this index.ts. So that's where I'm going to start from. So let's think for a moment about what our actual goal is. Normally, when we create resources in the cloud, we do it by constructing objects that represent those resources that we want. For example, when we want to create a new S3 bucket, we do something like bucket equals new aws.s3.bucket, and then pass in the various parameters. So what we want is a very similar situation, but for our own service, so I'm just going to call it mock service, where we can create table resources like this. We then pass in the various parameters that describe our table, and then at deployment time, we want Pulumi to call those various endpoints on our REST API in order to actually create or update or delete the table. And so that's the bit that we need to implement. Let's start by implementing this hypothetical resource object that we've got here that represents a table. So I'm going to create a new file, and I'll call it table.ts. I'm going to import Pulumi because I'm going to need that. And then I'm going to create a class called table, and it's going to extend pulumi.dynamic.resource. Now, if we think about what this constructor should look like, we're actually quite familiar with these arguments because it's the same as all the times that we've instantiated Pulumi resources ourselves. It always starts with the name, that's Pulumi's name for it. We then get what we call the props, so these are the resource-specific arguments, and just for the moment I'm going to leave that as any, but we will strongly type that in a minute. And then we get the optional options, and the type of this parameter is pulumi.customResourceOptions. We then need to call the superconstructor, and you'll find that almost all of this stuff is handled by the superconstructor, so largely you just pass all of these values up. The first thing we need is a resource provider, and I'm just going to gloss over that for a moment, and I'm going to leave that as null. But I'm going to focus first on passing in the name, the props, and the opts. Okay, so that's a start. We've got our table object. Let's now strongly type these properties like we wanted to. So the actual nature of these properties are going to depend on what the service is. So let's look at the mock service. And if we look under the post table request, we can see the various parameters that I've allowed for creating a table record. And by the way, these are basically meaningless. I've given tables a size for some reason. I don't really know what that means. It was just an example so that I could have a few different properties. So don't get too hung up on what they actually mean. So I'm going to copy those for reference because those, of course, are going to be the same properties that we can pass into our table resources when we create them. So let's make an interface for this and call it table inputs. And I could just leave it like this, but the thing is, because these inputs have primitive types, that means that they're not capable of accepting Pulumi output values. And as we know, it's very common for us to pass Pulumi outputs into the inputs of other resources. Like, for example, in the future, we might want to create a table whose name is based on some other Pulumi resource, the output of some other Pulumi resource. So we definitely don't want to leave these as primitive types. Instead, we want to change them to Pulumi.input and then pass in the actual type as a type parameter. And Pulumi inputs are capable of receiving the actual primitive type if you want to, but they can also take Pulumi outputs, and I think promises as well. They're basically just a shorthand for all those different possibilities. So now we can go ahead and we can strongly type our input properties. So put that as type table inputs. And so now we've started to define the interface that our dynamic provider is going to present. Let's put this into our main program so that we can start to see how this is going to build up. First of all, I'm going to import my mock service. Well, I'm going to do it like this. So then I can go ahead and I can construct a table resource. And I probably want multiple tables in my system. That's part of the advantage of writing a dynamic provider for it. So I'm going to have a table that represents my users. And so that is going to be a new mock service.table. I'll call it user table. And then I can pass in my various options. So let's call it users. This size is it's completely meaningless. Let's just give it something like that. And then read only, again, something you probably not that likely to have on a database table, but I just wanted something to make it interesting. So now I think we're starting to see what it will look like to use this dynamic provider and what kind of interface it gives to the developers who are using it. But what we're still really missing is a provider. That's what this argument here should be. So the provider object is going to be the one that actually implements the CRUD operations for managing this table, and that's where we're going to call the endpoints on our service to perform those CRUD operations. So let's go ahead and do that now. I'm going to create a new file and call it table provider. I'll import Pulumi. And I'm going to declare a class called table provider, and this time it implements an interface called pulumi.dynamic.resourceProvider. Now it's complaining, of course, because we haven't implemented any of the methods yet, but before we do that, I just want to export this class, and I'm going to hook it up here so that I don't forget to do that later on. So let's import table provider from table provider, and what I'm going to do is just construct a new instance of my table provider. And again, it's complaining because I haven't implemented any methods, but at least it's all now in the right place. Once I implement this method, it should start working. So the first method to implement, and actually the only one which is strictly required, is the create method. So obviously this is going to be the one for creating a new table resource. It's an async method, and as always my IDE will help me get the signature correct. So I'm going to copy that, although it's actually using arrow notation, so it needs a bit of fiddling around like that. And we can see that the create method takes some inputs and returns this create result object. Let's talk about these inputs first of all. These inputs are going to be the props that came from our resource object, except that by this point Pulumi will have resolved any of these values which were actually Pulumi outputs. So in other words, if I copy this interface here so that I can strongly type the inputs to my create method, I'm going to call that table provider inputs. It'll be the same except the actual raw values rather than potentially being wrapped inside a Pulumi output or a promise or something like that. Now, the fact that the outputs have been resolved is actually a bit of a clue to something that I'm going to talk about a lot throughout this video, which is the way in which Pulumi executes in two stages. The first stage is the preview stage, which is when it actually executes the code in your index.ts, and so therefore, in this case, that includes the code here, constructing the table resource and everything. All of that happens in the first step, when it builds a representation of the stack that it wants to deploy. Then, separately, in a second step, it goes ahead and performs that deployment. And so that means that this table provider class and all of its methods will actually execute in a different context to this table resource and your index.ts. That's going to become really important a number of times throughout this video, so I will keep coming back to it. But the first implication of these two separate stages is that all of those provisional values, those output values that were given to our table resource, will now have become real values in our provider, because we've reached that point in the deployment where other resources have now been deployed and we've got their real output values. Now let's look at what needs returning. Well, our IDE tells us that there's a couple of things. First of all, the ID of the created resource. Well, that's fine. Our mock API returns a unique identifier for the table, and you're likely to find something similar for any kind of resource you create. And then there's also this outputs field. So these are the output values that came from that creation. We will be using that, but we'll go into that later in the video. Anyway, first of all, let's think about how we can actually create the table. The code we write here, of course, depends entirely on the service that you're working against. In my case, it's a REST API, which I think is probably not uncommon, but you might be doing something else here, like calling a GraphQL API, or maybe something completely different in order to create your resources. Looking at the documentation for my mock service, we can see that to create a table resource, we make a post to this /table endpoint, and then we pass in a structure, as we know, with these parameters. And what we get back is a JSON encoded table object, which is defined up here, and you can see on there is the ID field. So I think all pretty standard. So let's go ahead and write the code for this. The first thing is I'm making an HTTP call, so I am going to have to install node fetch. And when you're in TypeScript, don't forget to install the types as well. Let's import it. And now I can call fetch to call my endpoint. The method is post, of course. And for the body, we might be tempted to just serialize these inputs to JSON, because we know that the inputs have the three fields that we're looking for. But actually, this inputs object contains more than just the types that we defined on our interface. We'll be talking more about it later in the video, but for now, I'm just going to say that it's actually much better practice to be explicit and just say that we want the name, size, and the read-only field. Finally, I'm just going to put the right headers on. And I'm going to do some really basic error checking, but because it's just a sample, all I'm going to do is just check whether the status code is 200, and if it's not, I'll just throw a new error. You probably want to do something a bit more substantial, a bit more meaningful, better error messages than this. But obviously that's going to depend on your service, so I'll just leave it like that for now. Now I can parse the body, and from that I can get the ID field. And so that's what I'm going to return in my create result, just return the ID. And as I said, there's also this outputs parameter. We'll look at that in a little while. For now, this should be a very basic working provider that will create table resources. So let's test it out. I've got my service running in the other terminal, so I could look at that to see if it worked, and I'll run Pulumi up. The preview looks good. It's trying to create the table, and it says it was successful. Let's look at the logs of the service, and yeah, it looks like it was successful. It's added a table with the name and the size and the read-only values that we gave it, and what we got back was an ID. So it's a good start, but this provider is not going to be very useful if all we can do is create objects. If we want to fully manage our state, at the very least we want to be able to delete them as well, so that we can destroy our stack and clean up afterwards. So let's now implement another method on our provider, the delete method. The delete method is nice and simple. It takes as an argument the ID of the resource that we're trying to delete, and that comes from the create method. It's this ID here, so after creation, Pulumi will store this ID as part of the object state, and so then it can pass it into this field when delete gets called. And the second argument is props, and this is the point at which this outs parameter that we could have returned from our create method becomes relevant. You will find that Pulumi uses slightly different terminology to refer to the same thing in different places. And in this case, these outputs, refer to the state that you want the object to have from this point onward. So at the moment, our object, it does have an ID because Pulumi always gives it an ID, but otherwise it doesn't have any other state attached to it. That includes all of the things that we passed in as inputs. And most of the time, this isn't what you want. Generally speaking, I think that you want all of these inputs as part of your state, or most of them anyway, because they are often really important for other methods. For delete, maybe less so. Perhaps there's a situation where you need to know what some of the original input properties were before you can delete a resource. I think we'll see a situation where that's the case later on. But even more importantly is for things like updating, which we'll look at later. We're going to need to know, if we need to know whether the name has changed, for example, then we need the name to be on our object state. And so for that reason, what I'm going to return in my outputs here are those three input properties, just like this. Anyway, that was kind of an aside that doesn't actually affect how we implement the delete method. So to implement it, we just need to make another call to fetch. Just quickly referring back to the documentation for the service, you can see that to delete a table, we just send a delete request to table / and then the ID of the table object. So that's simple enough to do using fetch. Make sure we set method as delete. I'll do the same basic error checking that I'm going to do everywhere. And then for deletion, there's nothing to return. In fact, actually, I'm going to get rid of that because that's implicit. So that's our delete method finished. To test it, why don't we destroy our stack? Now, it's worth watching carefully here because I'm purposefully doing something that's not going to work because I want to illustrate an important point. So you might think, well, I've implemented my delete method. Let's Pulumi destroy. The preview looks fine. And it says that it deleted it. But if I look in my logs for my service API, you can see that it never made a call to delete. So why did that happen? It's due to a really important subtlety, again related to this idea of Pulumi working in two stages, that's going to be really important throughout this video. And it's the fact that when you create your table resource, and you pass in your table provider that you've constructed, bearing in mind that this is happening during the first stage, the preview stage, what Pulumi does is it serializes this object. So it turns it into some binary form, and then it stores it on the state of the resource. That, by the way, is the reason that I said that these inputs here have other things on them other than the three things that we're aware of. Because one of the things is the provider. You will actually see it. If you console log this object here, you'll see that there's an additional parameter field called __ provider, I think, that has the serialized code for this provider object here. So it stores the provider code along with the state. And so that means that when you delete a resource, it doesn't read the provider from disk. It doesn't just read the latest version that you've got saved in your directory. It instead uses whatever provider was serialized along with the object. And so in our case, when we created that object, this delete method didn't exist. And so that means that the version of the provider that is being stored in the object state, and therefore the version of the provider that it used when we just did that Pulumi destroy call, was the old version that didn't have this. And so that's why the delete didn't actually work. Pulumi basically just silently didn't delete it because this method wasn't implemented. I think I can see why Pulumi is implemented this way. I think in some cases you could argue that, well, if a resource was created maybe a long time ago and the code for the dynamic provider has moved on since then, it could potentially break things if you try to delete a resource using some new version of the code when it was originally created with the old version of the code. So we should delete it using the code that existed when the object was originally created. And I can see an argument for that. There are probably lots of situations where that works. But I also know anecdotally that when you're developing dynamic providers, this will come back to bite you a number of times. So that's why I wanted to mention this as early as possible. The question then is, well, what should we have done? And the answer is that we should have done a Pulumi up first of all, because what you'll find is that by updating the resource, you don't just update the parameters that we've chosen, you also update that hidden provider property. Sometimes you'll see that in the preview. If you haven't changed anything else, but you've changed the provider, when you perform Pulumi up, it will say, I am updating your resource, and I'm updating it with a new provider. If we'd done that first and then did Pulumi destroy, it would have had the latest version of the provider, and the destroy would have worked. In any case, the resource is gone now, so we just need to do a bit of cleaning up, because we now have an orphaned resource on our cloud service. Pulumi thinks that this thing has been deleted, it's deleted its state for that object, it doesn't think it exists anymore, but of course it does exist, and I'm just going to do that simply by deleting the data file that represents that object. But of course, on a real cloud provider, you'd probably need to go into their web interface and go and delete that orphaned object. This is also a good time to mention that when you're developing dynamic providers, you will inevitably get into that situation where your Pulumi state becomes out of sync with the real state on your cloud provider. When it's this way round and you end up with orphaned resources, that's a bit easier to deal with because it doesn't break Pulumi. It's just wrong in the cloud provider. But when it's the other way round and Pulumi thinks something exists, but it doesn't exist in your cloud provider, you can get into real difficulty where you can't update the stack and you can't delete the stack because Pulumi is constantly trying to update or delete this resource that doesn't exist. For that reason, if you're not familiar with this already, I really recommend going back to watch a video I made earlier in this series where I talked about manual state modification. It's only 5 minutes long, but I talk about how you can manually modify the Pulumi state when you end up in those situations where things are out of sync. It really is something you're very likely to encounter a lot when you're developing dynamic providers. Anyway, now that's out of the way, why don't we test our delete for real? So I'm going to do Pulumi up again. It's going to create a new resource. This time it'll create it with the new version of the provider anyway, so it's definitely going to have that delete method this time. We can see that it did call our service like we expected. And so now let's destroy the stack. And this time we should see that it calls the service again, but this time with a delete. And there we have it, that's working now. The next thing I want to address is how we can add outputs to our resource object. So usually when we write a Pulumi resource, we expect to be able to get some of the output values that were given to us by the service and so weren't known in advance, but we then want to use later on for something else. So for example, we might want to get the ID. Now the ID, because that's a special case, Pulumi required us to return an ID, that output already exists on there. So I can, for example, say user table ID equals that, and if I update my stack, you'll see the ID there that's come from the service. So getting the ID is useful, but it's often typical that you can get the original input properties as well. So for example, the name. I mean, of course, we know what the name is already because we passed it into the object in the first place, but it's not always convenient to have to pass that name around. It would be nice if we could just say user table name equals user table dot name. And this is a pattern that you'll find that all of the official Pulumi resources also follow, so it's something we would like to do ourselves. In this case, the only reason that it doesn't work is because of the type system. The type system doesn't know about this name field, so we need to tell it that it exists. And it will actually exist because Pulumi will dynamically add it onto the object. So if I add a read-only name, and its type should be an output, and then special case for TypeScript, because TypeScript can see that this is never getting set in the constructor, you just have to add this exclamation mark. That will satisfy the type system because that error's gone away. And Pulumi was already adding that property dynamically onto the resource object for us. So there's nothing else that we need to do. If we run Pulumi up, we'll now see that appear as an output. And that's worked nicely. So ID is added automatically. The inputs are added to the object dynamically, and we just have to tell the type system about it. But what about things that were not input parameters, things which came from the service, and which are not the ID fields that Pulumi already knows about? We have an example of that on our mock service, because the mock service will actually return the created at and modified at times for every resource that gets created. So that's a good example of something that came from the service, and we may legitimately want to get from the object as an output. So we're going to have to do a bit more work to make that one work. There's actually two things that we need to do, and it's one of the places where dynamic providers are a little bit unintuitive, and it took me a while to figure out what was actually going on here. The first thing is that we go to our table provider and we simply add the fields that we want into our outputs. So in this case, I want to add created at, and we can get that from our result body, of course, because we get this information from the service. And same for modified at. But that by itself isn't enough to get them added to the resource object. Remember just now how we learned that Pulumi is dynamically adding all of the input properties onto the resource object. Well, we actually take advantage of that same mechanism, but it's a bit strange. What we have to do is we have to change this props so that it includes all the things that it had before, but also includes the created at and modified at fields. The thing is, of course, we don't know what they are yet, so it doesn't really make sense for them to be inputs. And this is why I think this is quite unintuitive. So we just have to set them to null. Their actual value doesn't matter because they're just going to get passed into the provider where they're going to be ignored, and then when the provider finishes creating, it will then set them with their real values. But it's just the fact that they exist in this object that's going to make Pulumi add them to the resource object. So now we can add some read-only fields for the type system's benefit. And let's go ahead and test this. And I'm going to have to do it by, first of all, destroying the stack. That's because the table resource that I have in my stack at the moment doesn't have those created at and modified at fields because when it was created they didn't exist. So I'm going to need to destroy them and then create new ones which will use the newest version of the provider. And that has succeeded, but just to emphasize again that it wouldn't have worked if I had missed off these slightly strange null values in the input props, or if I had forgotten to add them as outputs from the create. You need to do both of those things for that to work. Anyway, let's carry on and implement another important method that we're missing, which is the update. So let's have a look at what the signature for that is. So for an update, we can see that we get the ID of the resource, so we can identify the resource that's being updated. And we also get parameters called olds and news. And these are the props, that is the state of the object before and after the update. Olds is the property values that Pulumi is currently holding in its state for this resource. And then news are the new property values that are being passed in and that Pulumi detected that there was a change, and so that's what we want to update the properties to. So just to be clear, this is a situation where perhaps we've gone into our index.ts and let's say we've changed users to, let's just change it to users2, and then we've run an update and Pulumi has seen that this is now different from what it currently holds in its state, and so it will then have called the update method, and olds will contain the old values where name was users, and news will contain the new property values, including the name field having the value users2. So hopefully this will be quite straightforward, and let's just have a look at what the return value is. Well, all it is the outputs, because of course the outputs may change after this update, so we need to reassert what are the new property values now that we've tried to make this change, because some of these outputs, as we know, come from the service, and so they might be different from these new property values that the user tried to give us. There may be additions, they may even be slightly different somehow. So onto the actual logic. Let's again look at our documentation, where we can see that there is this patch endpoint where we provide the table ID in the path, and then the JSON body contains the fields that we want to update. For the time being, I'm going to keep this simple, and I'm just going to update all of the fields. And this is one of the things where you can see that there might be some complexity that is going to depend on your particular service provider. It'll depend on whether on your service you even can update individual fields, or maybe you can only replace the whole object. So I'm just going to show an example, and of course you may need to vary this logic depending on the actual service that you are working against. So let's call fetch as always. Set the method to be patch. Set the body to just be a JSON object with just those three fields. As before, I think it's good to be explicit. I could probably have just passed in the entire news object, but then that may contain other things that I didn't actually want to pass it, like the provider, for example. And then just the headers. Going to copy my same error handling and getting the result body, because I don't think any of that will be different. And then finally figure out what needs to go in here. And the important thing is that you want to make sure this matches the same outputs that came from your create method. You don't want to get in a weird situation where there are some properties that exist when it's created, but then when it gets updated, some properties disappear or some new ones get added. So you want to make sure this is consistent. So let's go up to our create, and I might as well just copy this. And obviously just change this to news instead. Great, so now we can test this. And just to keep you thinking in the right way, let's remember the fact that we've just updated this provider, but we already have an object that Pulumi is tracking the state of. And at the moment, that object has the old provider as part of its state. Now the question is, if we perform a Pulumi up where we've both changed the provider and we go and change some of the input parameters, which will happen first? Will it update the provider first and then use that new provider to perform the updates? Or could we potentially get into a situation where it tries to update before it's changed the provider with the old provider? And I have to say that the honest answer is I'm not entirely sure. I'm pretty certain that it will be fine and that it will always use the new updated provider if you're doing Pulumi up and you've changed the provider. But I'm not 100% sure whether there's a situation where you can get caught out and your updates happen with the old provider before the new provider gets updated. So just to be on the safe side, and I think probably just a good habit, to be in. I'm going to run Pulumi up now. So basically I'm updating my table resource to give it the new provider, even though I'm not actually doing anything with the new method that I've implemented yet, just to make sure that it's up there. Although I'm contradicting myself because I forgot that I had actually changed that. So sorry, I'm going to change that back to users. Don't do that update. So run Pulumi up, update the provider so that I feel safe that that is going to use the newest version of the code when I do actually perform an update, just to be on the safe side. And now let's test it by actually changing the state and causing it to call that endpoint. So let's change users to users2 and run Pulumi up. We can see that it wants to update. We'll say yes to that. And it looks like we've been successful. For one thing, we can see that our output that had the user table name has correctly changed to users2. And if we look at the service, we can see that it did indeed call patch with the new name for the users table. So it looks like that's working nicely. And actually what would have been particularly nice to test would have been the modified at, because that one's a bit unique, because this one is going to get changed when we perform an update. Like say if we change the name again, I'm going to change it to users3. The modified at also changes. So that's something worth checking to make sure that we wrote our update correctly and that we are returning all the correct outputs, because we should see that not only does that name change, but the modified at changes as well. And we can see that that's worked because that is the current time here. So we've covered create, update, and delete. And so at this point, you've possibly got enough to write a basic dynamic provider now. But there's quite a few things that I haven't covered that I really think are worth knowing, because they are things that you're very likely to run into. Let's return once again to this idea of Pulumi performing its updates in two stages. First, the preview that runs in one context, and then the deployment running in another context. A really good example of where this context becomes very apparent is when you try to read from your configuration files. So let's give ourselves a very realistic example that I think you're very likely to encounter, which is that in our table provider right now, we've hard-coded this endpoint everywhere, this localhost endpoint, and that's very unlikely to be what we want. We'd like to use this provider against different endpoints, especially because we might have a local instance, and then we might also be running it in production or on a development stack or something. So let's start by adding that to the config, and I'm going to put it in a namespace that's named after my service, which for me is just called mock service. This again is a common pattern you'll see. You'll know if you've worked with AWS, as I have done in previous videos here, that there is an AWS namespace where you set your config, like your AWS region, for example, and the AWS provider reads from that namespace. You'll see that this is a typical pattern that Pulumi providers use. So I would stick to that whenever you're fetching config from inside your dynamic provider. Let's call this endpoint, and I'll set it to, obviously, its current value. But it means that I could change that in the future. So now we need to get that endpoint value in our provider. Unfortunately, that's not as simple as you would think. You might think, well, I know how to do this. Just new pulumi.config, pass in the namespace. But this will not work, and it's because your provider is running in this different context. And one of the big differences about this new context is that you don't have access to your configuration anymore. The only solution is to read your config from the context where you are allowed, the obvious place being inside our table resource object here. So we'll read the config up here before we do anything else, and then pass it in as a property so that we then have access to it inside our provider. So that's what we're going to have to do. Say const config equals new config, and then I'm going to add an endpoint on here, which will be config.require endpoint. Now let's go and update our provider. So create, that's simple enough. It's going to come from the inputs here. So let's just change this. I need to change it to different kind of quotes, and And of course I need to add it onto my interface as well. So that should now work. And again, you can see this is another reason why when you're making your calls to your service, it's much better to just be explicit about which fields you want, because otherwise we'd now end up in a situation where we were passing endpoint along in here if we just passed the inputs object as it was, and we don't want to do that. What we also have to do is make sure that we add this endpoint to the outputs of our create function. That's because when our other methods are called, like for example update, that's also going to need this this endpoint that came from the configuration, and the only way it can get it is through the state. So we need to export it here, and that will allow us to then use it in the let's say news, because they might have updated the endpoint, and likewise with the delete, where it's going to come through. This time the parameter is called props, but it's the same thing. This is also a great example of the pitfall I mentioned just now of forgetting to keep the output from your updates in sync with your create, which I discovered just now on a previous take of this video and had to go back and redo this. So I think actually this would be a good argument for strongly typing these outputs. I'm not going to do it here just for this demonstration, but it would probably make sense to create an interface if you're using a strongly typed language like TypeScript, where you can define the outputs that you're expecting, and that hopefully will make sure that you keep them consistent between your create and your update method. Anyway, since we've made a change to the provider, I'm going to go ahead and run Pulumi up to update the provider before I go and change the endpoint. You can see that it's detected both the provider has changed and the endpoint. That's actually now a new property that it didn't have before. And now we should be able to test this out. Let's change this in our config and change this to 4000. And along with that, let's actually change the port that the service is running on. You can do that just by passing the port number as an argument. And so now that we've changed the config to point to the new endpoint and we've moved the service to be on that endpoint, you would think that everything will work fine. Well, I'm going to use this opportunity again to show you something that won't work to try and get you thinking in the right way. It's similar to the first time I did this, which is what happens if I now try to destroy the stack. The thing is that we are now in this slightly strange situation that I'm not sure is necessarily the best idea, but there's no other way at present that you can do this in Pulumi, which is that the endpoint against which we are performing these CRUD operations is part of each resource's state. So when you create a resource, it actually stores the endpoint that it was working against. And if you delete it without trying to update it with the new endpoint, when it deletes, it will try to use that endpoint that it had stored. So I'm just going to demonstrate that here. You'll see that this destruction fails, and it fails because it can't find, it's trying to talk to the old endpoint still, which no longer exists, and so that isn't going to work. And again, I can see why there is an argument for this being a good idea. You could say that, well, when the resource was created, this is the way that things were, and things may have updated in a way that will break the ability for our original object to get deleted. So we should just use all the original parameters that we had when the object was created when we delete it. But here's a good example of where that's actually not a great assumption. And there are some others that you might encounter. The one that I often run into is credentials. Let's say that you have some API key that you use to authorize yourself with the service that you're using. What happens if that API key changes? And usually if an API key changes, it means that the old one is no longer valid. You know, maybe it happened for security reasons because your old key got leaked or something like that. The problem will be that all of your existing resources will still have that old API key, so you have to update them with the new API key before you can destroy the resources. So we need to do exactly the same thing here. Before we can do anything else with this resource, we need to run Pulumi up, and you'll see that that is when it will update the endpoint associated with the resource. We can see here in the preview that it's detected the endpoint is different. And now we should be able to do things like, for example, destroy the stack or change some of the parameters that cause an update to occur. Anyway, I'm going to put the stack back up. And you might have noticed something a bit strange about these updates when we change the endpoint. Let's see what happens if I change the endpoint again. Let's put this back on 3000. And now perform an update. We can see here that the endpoint has changed. But if we look in our service, notice that it still performed a patch. Well, that doesn't make sense because nothing about the actual table record had changed. We didn't need to send anything to the service. All we changed was part of that resource's state in Pulumi that was keeping track of what the endpoint was. But when you think about it, it makes perfect sense that that's happening because that's how we've written our update method. Update just gets called whenever Pulumi has detected a change in the parameters. It's another reason why I think storing the endpoint in the parameters is perhaps a little bit questionable. But in any case, we can get around this by performing a more explicit check between the olds and the news. That's why Pulumi gives you both of them to compare. So a really simple fix for this might be if olds.name is not equal to news.name, or the same thing for size, or then we will perform the request. So let's indent all of that. And if none of those things had changed, then it means that possibly the state has changed. So we definitely do want to return the outputs with the news. So let's just copy this. But for the ones that can't come from the news, we just put olds. So in case you didn't follow that, what it's saying is if any of these parameters have changed that we actually need to tell the service about, the name, the size, or the read-only flag, then we call through to the service and we figure out what some of these outputs are going to be based on what came back from the service. But if those important things hadn't changed, then it means that the update has only happened because Pulumi's representation of this resource's state has changed, but we didn't need to do anything else. So we'll just make sure that we return all the correct new outputs. So that's the new name, the new size, the new read-only, and then these things created at and modified at, they don't come from the input properties, so we'll just get those from the olds because we know nothing has changed. We know we didn't call the service, and the new endpoint as well. Let's go and check that this has worked. So perform an update just to update the provider first of all. Let's look at the service just to check. So there's been one patch so far, and let's just make sure that another one, we don't get another one. So if I change it to 4000, and now let's go change that endpoint. So I'm going to go back to 4000 again. I'm going to kill the service and put that back on 4000. And let's see what happens when we perform this update. What we're expecting to see is that the endpoint does change, and it will use the new endpoint in the future, but it's not going to call the service at this time because it doesn't need to. It's only Pulumi's state that's changed. So let's check the service. Well, that's worked. It didn't call the service. And has the output changed? Well, I'll tell you what, let's use this as an opportunity to reassert the fact that all of the outputs for the resources are available on the Pulumi web UI. So here's the screen for my stack. And if I go to resources, and then there's my user table. They always come out as a dynamic resource, which can be a bit unclear when you've got lots of them. But look at the endpoint. We can see that the endpoint did indeed get updated. So it did update the state, but this time it didn't bother telling the service about it. Whereas if I do something like change the name, we would expect this to make a call to the service. Checking in the service logs, we see that that has worked. Let's talk now about some of the other methods that we haven't implemented for our provider that we can do in situations where we need them. The first one is the diff. So up until this point, Pulumi has been comparing the inputs that we've given to our table resource against its own state and figuring out from that whether anything has changed. And up till now, it's done that exactly the way we would expect. But sometimes we might have specific requirements about how states are compared. And I've come up with a simple example. I'm sure there are better, more realistic ones though, where I'm going to say that in my service, the names of those tables are actually case insensitive. And so when I am checking the inputs to my resource and comparing it against the existing state, I don't want it to trigger an update if all that's changed is the case of the table name. So let's have a look at how we would go about doing that. We have to implement the diff method. And just like an update, we get the ID of the resource, the old parameters and the new parameters. So that's all we need to make a comparison and see if an update needs to occur. And then let's look at the object that gets returned. I'm going to talk about all of these fields, but let's start with this one, the changes field. It's a Boolean, and quite simply, this tells Pulumi whether or not an update needs to happen. So up until now, it's been using its own implementation where if any of the olds are different from any of the news, then changes is true and it will trigger an update. But let's write some custom logic for that instead. I'm going to keep it really simple and just say changes equals olds.name. So for now, I won't worry about the case thing for the moment. Let's just get this working first. So I'm just literally just going to go through each of the parameters manually. I think you could probably do something nicer, like iterate over a list of parameter names or something like that, but I'm not going to worry about that for now because I just want to show the idea. And one question we might have here is, well, I've now checked the main three parameters for my table, but what about that endpoint parameter? Do I need to include that in my diff? I know that the endpoint changing does not actually have to call the service, but I did a quick check and I still do need to make sure that when the endpoint changes, I still return true from my diff, because otherwise it won't ever update the state at all. And remember that we do want it to update the state, we do want it to call through to the update method, and we've already changed our update method so that we don't bother calling the service when the endpoint changes. So we do need to include that here. The other thing you might wonder is, what about this hidden provider field? You know, if I don't check for that in my diff and I'm writing my own custom diff function, am I going to accidentally end up in a situation where I start ignoring changes to the provider? Well, I checked that as well, and it turns out, no, you're fine with that. Pulumi handles all that for you. You generally don't need to think about that provider field, although it's worth knowing that it's there. So that'll do for now. And so if I were to just return changes like that, I should end up with some pretty similar functionality to what I had already. Now let's change it so that we do this case insensitive comparison of the name. So just to be explicit with TypeScript, I'm going to tell it that those are strings, because then I can call to lowercase without the type system being with the type system understanding what's going on, which I think is a bit nicer. And so now we have some custom logic. That should mean that if any of the other parameters change, it just behaves like normal. If size or read-only changes, then it means it will call update like we expect. But with the name parameter, it'll perform this case-insensitive comparison. So let's do an update. You can see that this has actually changed the output in the preview. See, now it says that there are no updates, despite the fact that I have changed the provider. But as I say, I did do some checks. I think that's just a bit of a quirk of Pulumi. I guess it's because we've implemented our own diff method now, but you're not at risk of the provider not changing. I've checked and it does still work. So now let's test it out. Let's go here and first of all, let's do a change that should definitely trigger an update. So I'm going to change the size and run Pulumi up and see what happens. And that's worked fine. We can see that it's detected that the size has changed. So I don't need to go any further than that because we've already done the diff. We know it was going to update if we carried on. Now let's try something else and change the users. So let's change it in a way that would trigger an update. So I've actually changed it to users 2. And it doesn't matter what the case is, that is still different. So let's make sure that that triggers an update, and it does. And then finally, let's now try changing it to users with a lowercase u, and it should be that because of our custom diff logic, that will not trigger an update. And as you can see, it's worked. This time round, there is no update required. So that was a typical way to use the diff method, but there's a couple of other things that diff can do. Let's go and look at some of the other return values that we can return from our diff. The first one I want to draw your attention to is this one, called replaces. And this is useful in situations where instead of performing an update to our resource, we actually need to delete it and then fully recreate it. It's going to depend entirely on your service as to when this needs to happen. To give an example, you may have noticed when working with S3 that if you ever change the name of an S3 bucket, you'll see that Pulumi has to do a full replacement. That's simply because the S3 service does not allow you to rename buckets. They have to be deleted and recreated. And that knowledge is built into the Pulumi provider. Whereas if you change some of the other parameters about a bucket, you'll see that it can do an update and it doesn't have to delete the bucket first. In the case of my mock provider, this isn't true, but let's just show what it would look like if we did want to enforce something like that. So I'm going to make it so that when the size or read-only parameters change, it's fine, it can just do an update like normal. But when the name parameter changes, then we have to do a replacement. In other words, Pulumi has to delete and then recreate the resource. To do this, I'm going to start by extracting out this Boolean value for when the name has changed. So I'm going to pull that up to there into a constant of its own, and then I'll replace this with is name changed. And by the way, I've checked this, but you do still need to have this condition as part of changes. If you try to do changes is false, but then also add something into the replaces, it'll actually ignore it. Because changes was false, it won't try to replace either. So that's why it still needs to be part of this changes field. And let's look at what replaces is. So you might have imagined that it's a Boolean that tells Pulumi whether or not a replacement needs to happen. But actually, Pulumi wants to know more than that. It wants to know the name of the field or fields which have caused a replacement. And so that's why it actually takes an array of strings. So in our case, that's going to be something like this. If the name is changed, then you should return an array containing name, because that's the name of the property which is triggering this replacement. Otherwise, we'll just return undefined. So you can probably see how if you wanted to enforce replacements all the time, regardless of what changed, then you could just put some constant value here, some array that contains the names of all the properties, for example. But we're not doing that here, so let's give this a test. I'm still going to do this thing of running an update to make sure that my provider's up to date. I'm not always sure it's necessary, but like I say, I think it's a good habit to get into because at the very least it should avoid you falling into traps like when you try to destroy after changing your provider. So I think it's just a good habit. Anyway, now that's done, I can go and change some values. So let's start by changing a value that should trigger just a normal update. So there should be no difference in behavior here. I've changed the size. That should cause an update, and according to the preview, that's exactly what's going to happen. So let's let that happen. And just to confirm, let's look at the service, and we can see that it did indeed perform a patch, an update in other words. So that's as expected. But now let's try changing the name field. So I'll change it to users2 again. And this time, when we do an update, Pulumi should detect that we want to do a replacement instead. And just scroll up there on the preview, you can see that is what it's going to do. We don't have to implement a replace method, by the way. Replacement means that it's going to perform a delete and then a creation. So that appears to have worked. And let's just look in our service logs. And I'm hoping we're going to see something else that I wanted to talk about. Yeah, we can. So we can see that that worked. But you might notice something interesting, which is that it actually performed the addition before it did the delete. And that's because, for efficiency, Pulumi will always try to perform these operations in parallel when it can. So it didn't delete the resource, wait for that to complete, and then create the new one. It created the new one at the same time, and in fact, as we can see from the logs, actually very slightly before the deletion. In our case, that again is fine because our service doesn't really care about this kind of thing. But sometimes there are situations where you need to fully delete the object before you create the new one. That's because sometimes the old object might conflict with the new one if there's some property, for example, that has to be unique, and so you need the old one to be fully deleted before you can create the new one. In any case, it's simple enough to do. All we have to do is go to our diff method and also return delete before replace as true, and you'll find that that will change its behavior. So let's change our name again, change it back to users. It performed a replacement as we expected, and let's look in the service logs, and this time we can see that it appears to have done it in a different order. It deleted first and then it created the table. So there's one more parameter you can return from the diff method, and that is called stables. And as you can see from the docs, this is a list of properties that will not ever change. To be honest, I've never actually used this, and I think the only reason it exists is because there's some situations where Pulumi can figure out what certain output values should be at the preview stage instead of at the later deployment stage. So if anything, it's more of a kind of efficiency thing, I suppose. It's just a nice to have. It lets you know output values earlier, but I don't think it really changes any behavior as such. But something to be aware of. If you ever have any properties that you know are never going to change, then you can return their names in the diff function, and it will slightly optimize Pulumi's behavior. So that was the diff method, and we've got two more possible methods that we could implement in a dynamic provider. The next one I want to show you is the check method. The check method is nice and simple. Let's just copy the definition there. And it is just simply for validation. So you don't have to implement the check method, and your provider is likely to work perfectly well without it. But sometimes there are certain validation errors that are going to get caught on your service, but you could have caught them earlier. You could have caught them during your preview stage. And that's exactly what the check method is for. It gets called before creations and before updates so that you can check that the parameters that they are being called with are even valid in the first place. And if they're not, then you can just error out at an early stage. And it saves having to call the service and then waiting for that to fail. So the input arguments are just the props. It's the old props, if there are any, and the new properties, which there definitely will be. And let's have a look at what we return. You can see that we return this failures thing, and it's actually an array of these check failure objects. So the idea is that you might have multiple fields which have failed validation, and you want to report all of them. So let me just show you what that might look like. I'm going to add a new validation rule that I've just invented, which is that this made up size property that my tables have, I've just decided that it's not allowed to be greater than 128. And so that's something we can check during this method. I'm going to start by declaring my failures array, because I might want to put multiple things in here. So that is an array of pulumi.dynamic.checkFailure. Just initialize it to an empty array. Then I can do my check. So I'll say if news.size is greater than 128. Then I'm going to add into the failures array. And you can see that you give the name of the property. And I think that does need to match the exact name of the property, because Pulumi will use it to look up its value and report that to the user. And then let's just give some textual reasons. So the size parameter may not be larger than 128. And just for good measure, let's add another one. Let's say that also the name is not allowed to be longer than 16 characters. Okay, and then of course we want to return that in our check. So why don't we update this? And we can tell immediately it's working, because I'd forgotten that the size property that I'd already provided was already too large. So let's change it to something smaller, let's say 100, and then we should find this time that our update is successful. And the preview worked. With check, we only need to get as far as the preview, because it would have failed before then if it was going to. And then let's just check the other validation. Let's make this name really long. And that one has also correctly failed, so that's working nicely. The other thing we could return from our check was a field called inputs. And essentially these are sanitized inputs which we could do as part of our validation. So actually this is a different way that we could have implemented that lowercase check. Rather than just checking in our diff that the names were the same in a case-insensitive manner, perhaps we could instead have returned all the outputs or inputs, depends on the context, but also have set the name to be something like news.name to lowercase, for example, which possibly would have been a slightly nicer way to implement that. And so on to the final method that we can return. This method is called read. The purpose of this method is to fetch the actual state of the resource from your service. And this could be useful because you might be trying to update Pulumi's state with whatever is genuinely on the service, therefore keeping your service and your Pulumi state in sync. So we can see that the parameters are the ID, of course, so that we can uniquely identify the resource. Then the current state for the resource, because that could be useful for fetching from the service, which in our case, of course, it is, because that's where we store our endpoint, so we will actually need that. And what do we return? Well, we can optionally return a new ID. I can't quite imagine a situation where that would happen, where you would have one ID as input and then return a different ID, but I guess that is something you can do if you need to. And then more importantly, you can also update the props. So we can fetch the props from our service and then we can set this output here. And that's exactly what I'm going to do. So once again, I'm going to call fetch. I'm going to copy the usual thing that I do to just check the response code and parse the body. And then in here, we can then return the props, and we want all of them, or as many as possible, to come from the result body. Once again, for consistency, I am going to copy them from elsewhere. Let's copy them from here, from the update method. As I said before, it'd probably be really good to strongly type your props. Kind of wish I'd done that now, but I've come this far without doing it. So let's be clear about where these props want to come from. We want as many as possible to come back from the service. So they're all going to say result body, because the idea is that if you've got into a situation where the Pulumi state is actually outdated and your service has a more up-to-date answer, then the service is very much the single source of truth. The only one that we can't get from the service, of course, is the endpoint, because that didn't come from there. That was just always part of the props. So I'll just return that from the props. And that's how the read method should be implemented. But I do have to be honest here and say that when I'm trying to test this and illustrate how it works, I've actually had some mixed results. And so I'll admit I'm not entirely clear on how this is used. My understanding is that this method can be used by the Pulumi refresh command. So you may or may not be aware of Pulumi refresh. The idea of this command is that it will go through all of the resources in your stack, and for each one, it will call the read method. So it'll basically say, go get the real genuine state of this resource from the service. And then it will use that information to update Pulumi's state. So this can be really useful if things have got out of sync and Pulumi's state is out of date somehow. And it can also be useful for situations where sometimes you leave a parameter blank, and that means that on the service side, it gets some default value. But Pulumi doesn't know what that was. It still just has a blank value in its state. And refresh can be a good way of saying to the service, look, give me the full state of this object, and I'll use it to update Pulumi's state. And then you get all of those default values as well. And it definitely does use the read method. But when I tried to trigger this by changing things on the service side, I actually had slightly mixed results. And for some reason, I couldn't always seem to get Pulumi to call it. So I'm a little unclear on that one. But I'm pretty happy that this is how you go about implementing it. Anyway, now that we've implemented all of the methods for the dynamic provider, I think we've covered pretty much everything that you need to know about dynamic providers to go ahead and implement them yourself. So I'm just going to give a very quick overview of what we've covered in this video. The first thing we did was we implemented a resource object, and this is essentially the interface to our dynamic provider. It's an object that represents the resource that we can instantiate as part of our main Pulumi program. So like for example here where we're instantiating our table object. In order to make this interface nice and clean, we defined the inputs, the possible inputs that a table could have, and we made all of these the Pulumi input type. And that allows them to take either the actual primitive types that they wrap, or to take Pulumi output values that have come from other resources, or indeed promises or other things like that. We then implemented the constructor such that it calls the superconstructor with certain parameter values. So those parameter values included all the input properties that have been passed into the object. We also added to that these sort of fake input properties that are only there because we want to force Pulumi to dynamically add these things as outputs at a later date. So that's what these two are. And also any config that we wanted to fetch, because we can't fetch it inside the provider because that runs in a different context, we have to fetch the config values here. And so that's what we did with our endpoint. Speaking of the provider, that's something else that we had to pass into the superconstructor, which we've done here. And the important thing to remember about the provider is that it's going to get serialized. So in other words, it's going to get turned into some binary or text-based format and then stored as part of the object state. At a later stage, after the preview, when the actual deployment happens, it'll get deserialized, and that's the point at which it gets executed. By the way, this is something to be wary of because these props also get serialized, and sometimes that can cause problems. I think probably TypeScript is okay because I think pretty much everything in TypeScript can be serialized to a string. But in Python, I know that if you try to pass in objects, for example, that are not serializable, you'll get an exception. So I think it's good practice, especially in Python, but probably in other languages, and I think in TypeScript as well, to try to just stick to basic primitive types and dictionaries in Python or objects in TypeScript and lists in Python / arrays in TypeScript, just to avoid any headaches further down the line. Because we're using a typed language, we also had to add these instance variables here that represent the outputs. But that's just for the type checker because actually Pulumi added these things on dynamically. It did name automatically because that was one of the input properties, and it's done created at and modified at because we explicitly added them to the list of props. Even in less strongly typed languages like Python, for example, you still might want to do something like this just to help your IDE along and to give you suggestions. So then we implemented the provider class. The provider class is one that implements this pulumi.dynamic.resourceProvider interface. And that requires, at the very least, to have this create method. The create method gets some inputs that come from the resource object, but note that these will now have been resolved such that if they were output values during the previous stage, they've now become real values, as it were, which is reflected in the interface that we wrote. We then do the logic to contact our service, whatever this is. So this is the bit that's going to vary enormously depending on what service you are working against. But the main thing is we extracted both a unique ID that came from the service, and we returned that in the ID field. And also we fetched any other outputs that we want to be storing in the object state. And we returned these outputs as well, in addition to all of the input values too. Basically anything that we want to be part of the object state and that we want to access later on in our update method and our delete method, we should return here. And we should be really consistent about this and make sure that we always return the same list of properties in our other methods. So in the update, for example, which allows us to compare the old parameters and the new parameters if we need to, and then make the appropriate call to our service to update the resource, we made sure once again to return the same set of outputs. Or in some cases, we may not even have to perform the update with the service because nothing updatable was changed. Maybe it was just something that needs to change in the state alone, like with our endpoint. And so that's what this situation covers. We might want to implement some custom diff logic. So this is for situations where you have a more complicated way of comparing the state for whatever reason, or for situations where you want to perform a replacement instead of an update in some cases. We might also want to implement the check method. This just performs simple validation and returns the result to Pulumi, and that means that you can check for validation errors before you go and contact your service with a creation or an update. It's good practice to implement the read method as well, and this is used for fetching the true state from your service so that Pulumi can use it to update its own state. Although, as I've alluded to, you should probably do a bit of research about that yourself before you start using things like Pulumi refresh, because I'm not entirely clear on this myself, and I think possibly there's something being missed. And then finally, we implemented our delete method. I hope you enjoyed this video and that you find it useful. Please feel free to comment below if you have any questions or any observations. And if you'd like me to make more videos like this, then it'd be really great if you could share the video with anyone who you think would be interested, and subscribe to the channel. Because if I'm able to monetize the channel, then it's going to give me more freedom to dedicate more time to these and make more of them. So please do subscribe if you're able to. Thanks for watching.